Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about the definition and terminology in graph theory. So very first thing is that what is a graph theory? So graph theory is nothing but a branch of mathematics concerned with a network of points connected by lines. And the subject of the graph theory begins in the equational math problems, but it has to grow into significant area. So the history of the graph theory may be specifically traced to 1735. So the mathematician what we called as Euler to solve the cosine bridge problem. So this is the puzzle. So earlier that is going to be solved by Euler. So the puzzle concerning what is the possibility of finding the path over every one of the 7 bridges that span a focal river flowing past an island. So what is a graph? So a graph refers to a function, or sometimes may be also represented as a plot. So in graph theory, the term graph does not refer to the data charts such as line graphs and then bar graphs. So instead, it refers to the set of vertices and then edges. And the vertices may be the points and then nodes, whereas the edges is nothing but the lines that is going to become the vertices. So graph is nothing but the visual representation of edges and vertices, and edge is nothing but the line between the two boundaries, and the vertex is nothing but the point where two or more lines meet, right? So the elementary mathematics, the graph refers to a function, or it may be sometimes a plot, but in graph theory, so the term graph refers to the data charts, line charts and bar charts. So these are all nothing but a graph theory. So normally a graph is nothing but a set of vertices or points and then nodes. And the edges, what is connected in between them, is nothing but a line, what we call to be called as edge. So the graph is nothing but the visual representation of edges and vertices, and edge is nothing but the line between the two boundaries, and vertex is nothing but a point where the two or more lines meet. There are different types of graphs like multi-graph. So that means multiple edges are going to be allowed between the vertices, and simple graph means a graph without loops with at most one edge between any two vertices. That should be a simple graph. And pseudograph means a graph that may contain the multiple edges and then graph roots. So what are different types of graph means? Simple graph. So a simple graph is the graph which may not contain any loops and then parallel edges. And multi-graph means a graph which is going to have the multiple edges in between the pair of vertices. And pseudograph is the graph that may contain edges and then graph loops. So this is one of the example of this pseudograph. So simple graph, no loops and parallel edges. If the graph is going to have multiple loops, multiple edges, then it should be multi-graph. And if I'm going to have loops and then parallel edges, then it should be pseudograph. So some other graphs also are available, like unlabeled graph or undirected graph. So this should be unlabeled graph. I can also write it as undirected graph. Then edge labeled graph. So that means for each edge, some weights are going to be assigned. So this one, what we call as edge labeled graph. And next, what we are going to have is vertex labeled graph. So for each vertex, I'm going to assign some number. So that should be vertex labeled. And next one, what is graph coloring? So we're going to discuss now. So the assignment of labels or colors to the edges or vertices of the graph. So graph coloring is nothing but the assignment of labels and colors to the edges or vertices of the graph is nothing but graph coloring. There are two common types of graph coloring. So first one is that edge coloring and the next one is that vertex coloring. So edge coloring is nothing but an assignment of labels or colors to each edge of the graph such that the adjacent edges must have different colors. So whenever I'm going to have the edges, so I have to be color with blue and this should be green and there should be some other color. And similarly I can able to draw here the under green here and I can also draw blue. So like this I can able to apply the different colors or labels to each edge of the graph, then I can able to say they should be an edge coloring. And vertex coloring is also similar, so an assignment of labels or colors to each vertex of the graph such that no two edge connecting between the two identical color vertices. So that means if I'm going to have a graph like this, then I can able to apply different colors here. So this is one color I'm going to apply. That should be red, and this another color blue, and another color green. So since the two adjacent are something different, so I'm going to apply red in this case. So this should be the assignment of colors such that no two vertices are said to be adjacent to each other. Okay, so the graph coloring is nothing but assignment of labels and colors to the edges of the vertices of the graph. So there are two types of graph coloring. So first one is vertex coloring and second one is that edge coloring. So edge coloring means the assignment of colors to the edges of the graph such that no two edges is going to have the same. And similarly, the vertex coloring is also similar. So it should be assignment of labels and color to each vertex of the graph such that no two edges connect between the two identical colors. Next one, so vertex color graph, edge color graph, and then vertex and edge color graph. So there are three different types of coloring vertices. So vertex coloring. So vertex coloring means so first I applied red here and green and then blue. Since it is also adjacent, so that's why I'm going to apply another color here. So we should be vertex color. So just now I said so apply green here, apply red, and apply yellow. So this is the edge color. So if I apply both here, so all this vertex and edge coloring graph looks like this. So what is four color problem? So the four color problem states that any map in the plane can be colored using four colors in such a way that the regions sharing a common boundary does not share the same color. So if you look at this region, so this is blue and this is green and this is red. So the region is not covered with blue here. Okay. So that means the region sharing the common boundary does not share a common color. So this is green here and this is red. So this is not shared with blue, so something different, and this is yellow and this is green and this is red. So the four color problem according to states that any map in the plane must be colored with four colors in such a way that the regions of this boundaries may not have same. So what is coloring actually? So the graph coloring is nothing but assignment of colors on any distinct marks to the vertices of the graph. So strictly speaking, the coloring is the proper coloring such a way that no two adjacent vertices have the same. Okay. So graph coloring is nothing but assignment of colors to vertices of the graph. So the coloring is the proper coloring so that no two adjacent vertices have the same color. So what is this coloring planar graphs? A graph is said to be a planar if it is drawn in a plane without edge crossings. So whatever the graph I'm drawing, so the graph which is going to be drawn in a plane is said to be a planar graph. So whenever the edges may not cross each other. So if I'm going to draw, this should not be a planar graph. Why? Because the edges are going to be crossed here. So that's why it should not be a planar graph. So this is another example of this graph. Right? So if you look at this edges, the edges are not crossing each other. So that's why it should not be a planar. So similarly, if I'm going to draw another graph, so this should be also a planar graph. So if I'm going to draw like this too, then I may not be a planar. So, so the coloring may be applied only for planar graph and may not be applied for non-planar graphs. So the four color theorem says that for every planar graph, the minimum chromatic number is less than or equal to 4. So if you take any planar graph, so the maximum or minimum number of chromatic number should be less than 4. So I'm going to take another graph. So this is the planar graph I'm drawing without edge crossing. Okay. So what is the colors I can able to get maximum? So this is one color, and this should be another color, and this should be another. So what color can I able to apply here? Apply this, again apply this. Then I can apply another color. So how many colors are needed for coloring this graph? So 3 colors. So 1, 2, and then 3. So like this I can able to apply the colors to the planar graph. So if the graph is planar without edge crossing, so maximum number of colors that are needed to any planar graph, any number of vertices is less than 4. So what is graph coloring? So normally speaking that, so the graph coloring is assignment of colors to vertices of the graph, and the coloring the coloring should be done in proper way of the graph. It should be and be complete. So that should be collective properties. So edge coloring. So edge coloring means that so we're going to assign the colors to edges of the graph in such a way that the not two edges is going to have the same color. So normally this edge coloring problem can be formatted as vertex coloring problem only. So let an angle of G should be an auxiliary graph, and G may be graph which is going to trying to show or trying to color, and L of G is going to be contain the vertices for every edge in G, and there is an edge in L of G between the two vertices. So auxiliary graph is almost similar to the given graph. So what is four coloring theorem? So the four coloring theorem states that any planar graph can be colored with at most 4 colors. So in graph terminology, so that means so at most 4 colors for any planar graph can be used. So vertex coloring, some of the examples. So vertex coloring already know that should be the assignment of labels and colors to each vertex of the graph such that no two vertices going to have same color. So these are some of the examples I have drawn. So vertex coloring, so which is going to have so minimum number of colors that are needed for this. So the minimum number of colors that are needed in this planar graph is that. So 1, 2, 3, 4, and here it should be 2 only, and here in this case it should be so 1, 2, 3 only in this case, and here also 3 only, right? So this should be the vertex color. And edge coloring, so already I told what is the edge coloring. So it is sometimes similar to vertex coloring, but we're going to be color the edges here such that no two adjacent edges is going to have different color. So if I'm going to consider this, so this should not be a planar graph. So edge coloring is done. So the coloring the edges of the graph is same as the coloring the vertices, and then every graph is a line graph, but every graph is a line graph of some other graph. So what are the properties of K coloring? So the K coloring of the graph is a mapping of vertex graph into integers from 1 to K such that the adjacent vertices map into different integers. So the K coloring partitions into K disjoint subsets that such that the vertices from different subsets have different colors. So K coloring of the graph is the mapping of G into vertices such that the adjacent vertices is going to map into different integers. And K coloring partitions are also going to be done into K disjoint subsets such that the vertices from different subsets have different colors. So explain the terminologies of graph coloring. So for this we are going to have K colorable. So K colorable means the graph G is K colorable if it is going to have K coloring. And chromatic number means the smallest integer K for which the graph is K colorable is called a chromatic number, and that should be denoted by XOH. So a graph G is K colorable if it is going to have K coloring, and chromatic number means the smallest integer K for which the graph J is K colorable is called the chromatic number of the graph. So if I'm going to show so what should be the chromatic number? So in this way the chromatic number should be 4, and here it should be chromatic number 2 and chromatic number 3, and in this way the chromatic number is 3. So those are the questions that can able to arise in graph coloring. So very first thing is that what is the 4-color problem? So graph is nothing but visual representation of edges and vertices, and edge is nothing but a line between the two boundaries, and vertex is nothing but a point where the two or more lines going to be meet each other. There are different types of graphs like multigraph, simple graph, and pseudograph. So simple graph is the graph which does not have any loops and edges, and then multiple graph means the graph which is going to have multiple edges, and pseudograph is the graph which is going to have self-loop and then edges. And graph coloring will be of two types like edge coloring and vertex coloring. So the edge coloring means the assignment of colors to edges such that no two adjacent edges is going to have same color, and similarly the vertex coloring also. So the vertex coloring again will be of different types like vertex coloring, edge coloring, and then vertex and edge coloring graphs. It's 4-color problem. So planar graph is nothing but a graph which does not have intersection of edges. So then only I can able to apply the color according to the 4-color theorem. That to the 4-color theorem, the maximum chromatic number should be less than or equal to 4 only. So what is NP-hard problem? So NP-hard problem is nothing but a class of Bayesian problems. So that is going to be solved in polynomial time on a non-deterministic machine. Okay, so is a class of Bayesian problem which is going to be solved in polynomial time on the non-deterministic machine or non-deterministic algorithm. So deterministic computer means what we know, but non-deterministic computer means that you can able to guess what should be the right answer or solution to the problem. So NP can be thought as a class of problems whose solutions can be verified in polynomial time. So what are the examples of NP-hard? So fractional knapsack, sorting, and other graph coloring and satisfiability. Satisfiability means that this is the problem of deciding whether the given Boolean formula is satisfiable or not. So fractional knapsack. So knapsack is nothing but a bag. So where we can able to insert the item, we can able to know the size of this knapsack. Let it be 10. So we have to be insert the item in such a way that the item size should not be exceed this knapsack size. And sorting is also going to have different types of sortings like selection sort, net sort, quick sort, bucket sort, radix sort, fetch, insertion sort like this. So all these problems are going to be NP-hard problem. So NP-hard problem is nothing but a class of ratio problem which is going to be solved in polynomial time on a non-deterministic machine. Okay. So what are the various applications of this graph coloring? So normally this graph coloring is going to be used in making timetables and then scheduling and register allocation and transaction. So a lot of this is also going to be done in this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.